Right now, most AI tools are passive. You ask, they respond, and then they just stop. But what happens when an AI doesn't wait for your prompt? Welcome to the Explainer. Today, we're tearing down OpenClaw. It's a highly controversial open source project that is shifting AI from just an isolated reactive chatbot into an active, always-on daemon. And as you're going to see, this shift changes absolutely everything about how we design and secure AI systems. To really understand the scale of what we're looking at here, check this out. OpenClaw just crossed 200,000 GitHub stars in record time. It hooks directly into your WhatsApp, your Slack, your terminal, and it runs continuously in the background. But contrasting that explosive hypergrowth is a pretty terrifying enterprise reality. Meta has completely banned it internally, security researchers are finding widespread malware campaigns directly targeting it, and tens of thousands of instances are sitting fully exposed. So here is our roadmap for today. We'll start with the autonomous paradigm shift, then unpack that 4-layer system architecture, dive into the terrifying threat model, and finally cover safe deployment and isolation. Let's get right into it. Part 1, the autonomous paradigm shift, moving from reactive to proactive. Okay, to transform a standard large language model into an autonomous agent, you really only need 2 absolute necessities: autonomous invocation and persistent state. So autonomous invocation just means the agent has the ability to wake itself up without human input. Think webhooks, cron jobs, or event listeners. Persistent state, on the other hand, means it actually remembers context across sessions and reboots. It knows exactly what tasks are pending and what actions it took yesterday. The crucial difference here is the execution scope. While ChatGPT waits for you in an isolated browser tab with its memory completely resetting every session, OpenClaw is durable and integrated. It runs proactively in the background. That means OpenClaw is fully capable of analyzing an event loop and texting you on WhatsApp at 3 a.m. saying, "Hey, I noticed the staging server was low on disk space, so I cleaned it up and pushed a new build." It literally acts on its own. Part 2, the 4-layer system architecture, applying OS and database principles to AI. If you're a system architect, these patterns are going to look incredibly familiar. OpenClaw functions identically to a local background daemon, not a web app. It applies classic distributed systems patterns, event loops, durable state, process isolation, across a 4-layer stack. Those layers are the gateway, reasoning, memory, and execution. Let's break these down. Layers 1 and 2 act as the brain and the central nervous system. The gateway layer is a local WebSocket server. Its job is to normalize chaotic, raw webhooks coming from WhatsApp, Slack, or system errors into a unified JSON format. It then feeds all that into the reasoning layer. Here, the engine manages dynamic per-session token budgets, compiling the system state and instructions into one master megaprompt for the LLM. Now, this right here reveals one of the smartest engineering decisions in the whole project. For Layer 3, it's memory. OpenClaw completely bypasses trendy vector databases. Instead, it relies entirely on plain markdown files on disk. To prevent context window collapse, because obviously LLMs have limited memory, it actually mimics Postgres. It uses a write-ahead logging architecture, persisting critical state changes as write-durable notes before running a context compaction that summarizes history directly to disk. It is essentially virtual memory paging, but applied to an AI's context window. Pretty brilliant. Finally, Layer 4 is execution. Because the agent is always on, OpenClaw enforces strict session isolation, directly mirroring OS process isolation. Background jobs run in isolated Docker containers. Without this firewall between contexts, a single agent trying to handle a WhatsApp message and a Discord shell command simultaneously would suffer from immediate context collapse. It would just become a very confused agent very quickly. Part 3, the terrifying threat model. Let's do the autopsy. So, security researchers recently audited OpenClaw's community marketplace, known as ClawHub, where users share custom agent skills. They discovered over 800 explicitly malicious skills. Let that sink in. That is roughly 20% of the entire marketplace. These attacks turn untrusted community code into a massive distribution network for Mac OS info stealers. And the terrifying part, these aren't obvious viruses. They are perfectly camouflaged as popular productivity tools, coding assistants, and API integrations. Their sole purpose is to execute a coordinated deployment designed to extract developer credentials and environment keys. But honestly, it gets worse. Let me walk you through the exact anatomy of a zero-click WebSocket exploit discovered back in January. Step 1. A victim simply visits a harmless-looking web page, maybe from a random Discord link. Step 2. Hidden JavaScript on that page attempts a WebSocket connection directly to your locally running OpenClaw gateway. Step 3. The gateway server completely lacked an origin validation check, so it just accepts the connection. And Step 4. Your auth token is stolen instantly. The devastation of this vulnerability is absolute. Full remote execution is achieved in milliseconds. 0 clicks beyond visiting the page, 0 passwords, 0 authentication bypasses required, just total system control simply because a local daemon trusted a browser request. Now, while this specific CVE was patched, it really highlights this exploding attack surface. When these info stealers actually get into your system, they aren't just looking for your AWS passwords. They target 3 specific files. You've got OpenClaw.json for remote access tokens and device.json for cryptographic pairing keys. But the most insidious target by far is soul.md. This is the plain text file defining the AI agent's core personality and operational rules. Attackers hijack this to fundamentally and invisibly alter how your agent behaves, effectively turning your own automated assistant into an insider threat. And if you're sitting there thinking this is just some theoretical local risk, well, independent scanners recently found over 30,000 OpenClaw instances. 30,000 instances sitting fully exposed on the public internet, directly accessible. Why did this happen? Because right out of the box, most instances were binding to default ports, with credentials stored in plain text files. It's an absolute enterprise nightmare. This right here, the threat of catastrophic lateral movement within a corporate network, is the exact reason Meta instituted a strict internal ban on the software. Part 4. Safe deployment and isolation. Let's engineer the fix. Look, you can never, ever run an always-on agent on bare metal. Safe deployment requires strict 2-layer rootless container isolation. Container 1 houses your gateway orchestrator. Container 2 is your execution sandbox. The sandbox has a read-only file system, 0 network access, and is highly volatile. If a malicious plugin tries to do something harmful, it simply destroys its own little sandbox, while your host machine and your gateway remain perfectly safe. But the tool you use for this isolation matters immensely. We strongly advise engineers to use Podman instead of Docker for autonomous agents. Here's why. Docker runs a daemon as root. If an AI agent executes a 0-day and escapes the container, they are root on your host machine. Game over. Podman, however, is rootless. If an attacker escapes, they land as an unprivileged user, vastly minimizing that blast radius. So let's summarize the absolute tactical rules for production security. First, always bind to localhost. Never expose port 18789 directly to the internet. Second, if you absolutely need remote access, use a reverse proxy with TLS and strong authentication. Third, manually vet your dependencies. Just assume all ClawHub source code is untrusted malware until proven otherwise. And finally, regularly run the diagnostic command OpenClaw Doctor to scan for permissive policies and misconfigurations. Let's bring this all together. OpenClaw gives us a fascinating glimpse into the future. Event loops, write-ahead logging, persistent state, these are the blueprints for how all future production AI agents will be built. But the threat surface is exploding. Every single integration is an attack vector. Every plugin is untrusted code acting with your identity. It requires rigorous, uncompromising InfoSec discipline to actually survive in production. Which leaves us with this final thought. We've spent the last few years worrying about AI hallucinating in a chat box. But as AI transitions from conversational novelties to autonomous daemons running local shell scripts while we sleep, is the tech industry truly ready for an attack surface where the AI itself is the vector? Think about that next time you give an LLM access to your terminal. Thanks for joining me on this explainer, and I'll catch you in the next one.